Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor Space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenters. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. The session will run approximately 1 hour with questions throughout, and I'll now turn it over to the speakers for introductions.
Great. Hello, everybody. I am Sam Wronski. I'm joined with Brandon Minnick, and today we are going to be talking about .NET Maui and how to do that. So this is part of our Unpacking build series. It's a series we're running to kind of take some of the things you might have heard about at build and dive a little deeper into them and learn how you can get your hands on them and start learning about how you can actually start working with these tools. So today we're talking about .NET Maui. So I'm just gonna throw it over to Brandon, who's gonna teach us all how to do awesome things with .NET. So
thanks, Sam.
Yeah,
I'm ready. Brandon Minnick here. I also work as a developer advocate alongside Sam at Microsoft, and have a strong background expertise in this stuff. I actually used to work at Xamarin. Xamarin was a startup that Microsoft acquired a couple years ago, and what we'll be talking about today is .NET Maui, which for me, as a former Xamarin employee, this is the culmination of the Xamarin acquisition. If you don't know or haven't ever heard of Xamarin before, don't worry about it. You don't need to know anything to do anything with .NET Maui. But if you have, we'll cover a little bit of that too. So great, I see the slides are up on the screen, so let's jump into it. Now, on the bottom of the slides, you'll see a couple things today. This on the bottom right, this is a web page that I've put together that contains all the content from this talk today. I've presented this talk at a couple other conferences that you'll find links to their recordings. That this webpage has the slides. It has open source samples that you can check out that we'll basically be building live today. So don't worry about memorizing anything. Don't worry about trying to keep up with any URLs or stuff we're looking at. It's all there on the webpage. So sit back, relax, and enjoy, because we'll be talking about creating apps with .NET Maui for iOS, Android, macOS, and Windows. So, like I mentioned, .NET Maui is the evolution of Xamarin Forms. If you've never heard of or used of Xamarin Forms, don't worry about it. You don't need to know anything about it to use .NET Maui. But if you have, you can almost think of .NET Maui as version 6 of Xamarin Forms. The current release of Xamarin Forms is version 5 right now. .NET Maui essentially brings in all of those technologies into the .NET SDK. So we're finally promoting all of the fun stuff that we've been doing for the last few years into .NET, which is really exciting. Now, .NET Maui actually stands for, it's an acronym, or Maui is an acronym. Maui stands for Multi-Platform Application UI. So it's a bit of a mouthful, but really what that means, it's a cross-platform UI framework. And what it allows us to do is build apps for Windows, like we see here on the far left, Android here front and center. This is the macOS app in the background, and this is the iOS app here on the front right. And all of these apps were built using the same exact code in .NET Maui. So the way .NET Maui works is we write code, and when we click compile, that code gets compiled down into the native UI for each platform. So what we do is say something like, put an image on the screen. Put an image of the weather and let us know what the temperature is. And then when we compile the app for, say, for iOS, that image will actually compile down to the native iOS UI image. Same with button. If we tell .NET Maui, put a button on the screen, when we click compile for iOS, that button becomes a UI button. Likewise, when we click compile for Android, it becomes a native Android widget button. So what we're seeing here is the same code running on 4 different platforms, but everything's totally native. This is actually using all of the same APIs that you would use if you were creating these same apps in, say, Java or Kotlin for Android, or if you were creating this app in Swift or Objective-C for iOS. It's the same exact APIs. It's a little bit more complicated, but really all we're doing on the .NET team is we take the iOS SDK that contains a couple 100,000 APIs, and we just wrap each of those public APIs and bring them into C# so that you're able to do anything you want using the same native iOS APIs that you would leverage in your Objective-C or Swift code. Same with Android. We just take the Android SDK and wrap that and bring all those APIs to C#. And so when you're making your iOS app, your Android app, your macOS app, your Windows app in C#, you're getting access to every single API that's available in the native SDKs. All of your code boils down into the native binaries, so you get the native performance, you get the native look and feel. For example, if we compare the Android app and the iOS app here, we're showing different pages of the app, so obviously those parts look different. But if we look at things like, look at this status bar here, the bar at the top where it says Redmond, Washington. The text is justified to the left, which is the default setting on Android. Likewise on iOS, that text is centered, which is the default settings for iOS. And we even on iOS, we get this back button here, so we can go back to the Redmond, Washington page. On Android, we would use the back button. So it's very similar look and feel because it's the same UI that we wrote in our .NET Maui code. But again, because when we compile our apps and it compiles down into the native platforms using all the native APIs, just like if we built this in Objective-C, Java, Kotlin, we still get the native look and feel for each platform. So one of my favorite things about .NET Maui is everything you can do in Objective-C, Swift, Java, or Kotlin can be done in C# with .NET Maui. All the APIs are there. There's really nothing limiting what you can do. And the best part is when you're done, you only wrote your code once, but it's going to run on all 4 platforms. So if we take a look at, looking under the hood, right? Like what is, or how is .NET Maui architected? This is a diagram that I put together. This is very much a Brandon made diagram because this is how I like to think of .NET Maui, and we'll actually dive into the source code for .NET Maui just a bit to see a little bit more about how all this stuff works. But at the heart of .NET Maui is this interface layer. So we have this big, long .NET Maui interface. And this, for all my Xamarin friends out there, this is the breaking change between Xamarin Forms and .NET Maui. So the good news is your Xamarin Forms code that you know and love, if you're familiar making Xamarin Forms apps in XAML and using things like collection views and buttons, all that XAML is pretty much the same, nearly identical. So that UI framework is up here. So that's your XAML code there. That's where your collection view lives. That's where your buttons live. That's where your labels live, your colors, all that stuff that you're going to write, or that we're going to write in our code that's going to appear on the screen. All that still is here, but what the team did for .NET Maui was added in this interface layer that essentially allows the UI framework, so all that XAML, that Mvvm code that we're familiar with in Xamarin Forms, that still exists, but it doesn't have to know or care about what platform we are running our code on or compiling our our code for, because all the UI framework has to do is implement an interface for everything. So we have interfaces like iButton, iLabel, and as long as the UI framework can implement that interface, .NET MAUI can take it from there. So the internal engine, the guts inside of .NET MAUI is really what it's doing is it's saying, give me an iButton interface because I know, because .NET MAUI knows how to create that iButton on iOS. So we'll check out some code in a bit that shows off how a UI button on iOS is created from that iButton interface, or how an Android widget button is created from the iButton interface. And the reason we chose to go this route and push through with, breaking changes, right? Like breaking changes are always scary for us developers, but the performance improvements we get by doing it this way in .NET MAUI, huge. In Xamarin Forms, everything is very tightly coupled. And you may have seen some slow loading times in your Android app, for example, because of the way that the original architecture that was created, over a decade ago back at Xamarin, was first implemented. But with .NET MAUI, we can see faster startup times thanks to this new architecture, which is great. So your app will launch faster on your users' devices without really having to do much. And the best part is we kind of can plug in all these different platforms. So right now, .NET MAUI officially supports iOS, Android, Windows, macOS, but let's say we wanted to add support for Linux. So that same code that we wrote in our XAML could just run on Linux. Well, to do that, we can basically plug in Linux into the interface. And as long as we define how to create an iButton and an iLabel and how to implement these interfaces on the Linux platform with the Linux APIs, then we just added another platform to .NET MAUI. And now all of our .NET MAUI code just runs on Linux, which is great. And then up here at the top, you'll notice there's these other frameworks up here. So just like we can essentially plug in a new platform and add, say, Linux or web support, which again don't exist today. That's why I've got the little question marks there, but yeah, could be something we do in the future. On the other side, we can also add different ways of creating our UI frameworks. So again, as long as the UI framework implements those same interfaces, then the .NET MAUI engine doesn't really care, because all it knows is I know how to make a UI button out of an iButton on iOS. I know how to make an Android widget button out of an iButton on Android. And so what that's enabled us to do is create new UI frameworks, which is really exciting. So you may have heard there is a way to use your Blazor knowledge on .NET MAUI too. So I mentioned this .NET MAUI XAML. That's very similar to Xamarin Forms XAML for those of you who are familiar with it. But for all of our friends who are familiar with Blazor, you can bring all of your Blazor knowledge or Blazor skills to create your .NET MAUI apps using the Blazor UI framework or the Blazor app model. And again, when you click compile, .NET MAUI takes it from there, and then next thing you know, your code made using your Blazor skills is now running on iOS, Android, macOS, and Windows. Likewise, we have a experimental new framework called Comet. This one's really exciting because it uses a completely different architecture. So with .NET MAUI, or with Xamarin Forms and the XAML approach, everything is done with the model view model architecture, also known as MVVM. With Comet, this introduces a new architecture that you may have heard of called MVU, Model View Update. MVU is quickly becoming a popular architecture in other developer communities, such as JavaScript, like React uses MVU, Flutter uses MVU. And so we have a new UI library available for anybody that wants to check it out. It still is experimental, but it's called Comet, and it allows you to, similar to Flutter, it allows you to create your UIs using C#. There's no XAML needed for Comet. It's just C# with the fluent, what we call it, fluent extension methods, and using the MVU architecture. So this is something I'm really excited about. I think MVU is going to eventually overtake MVVM as the most popular architecture. And so love seeing that we have these available. And plus, it's, well, we'll say easy, we'll throw that in quotes, to create your own UI framework and just plug it into .NET Maui again as long as you implement these interfaces. And so I put another one up here. There's a popular .NET cross-platform UI framework called Uno that's out there. And Uno, when it was first made years ago, runs on a lot of the Xamarin technologies. So if they wanted to, they could update the Uno platform to leverage all the work that .NET Maui does in creating iOS, Android, macOS, and Windows apps, and they could probably remove a lot of code from their existing UI framework. So this new architecture is really cool. It's really exciting. It gives us developers an easy way to essentially create our own UI frameworks, bring our own app models into the .NET Maui ecosystem, which ultimately allows us to then run those apps on iOS, Android, macOS, and Windows. So for all my Xamarin Forms friends out there, here's kind of a quick comparison chart. Xamarin Forms only officially supported iOS and Android. With .NET Maui, Microsoft has stepped up a little bit to include support for macOS and Windows. Xamarin Forms was created long time ago, back before even .NET Core or .NET Standard existed, but its minimum framework dependency nowadays is .NET Standard 1.0, whereas with .NET Maui, since we just introduced it in .NET 6, we've set .NET 6 as the minimum framework there. This way we get to take advantage of a bunch of, or all of, the goodies that we've gotten in .NET 5, .NET 6, along with all the incredible performance improvements that have come. So things like lower memory usage for string allocation, or lower memory allocations for strings. We get that for free in .NET 6, and so why not make .NET Maui's minimum framework .NET 6 so we can all enjoy all these new performance benefits from the runtime. One of the big differences, again, is this new architecture where in Xamarin Forms we had this concept of renderers. The renderer is what did that translation from the Xamarin Forms button into the iOS UI button. And the way it was architected was slow, it was really bulky, difficult to understand, required a lot of learning, especially for new developers. .NET Maui uses handlers, and we'll see what these look like in a little bit. So these are much faster. This is where we're getting a lot of our performance benefits. And then on the developer side, for us making our .NET Maui apps, handlers are also really easy to override, extend. So if we want to customize maybe some things that .NET Maui is doing, it's infinitely customizable and super easy. We'll see how to do that in just a bit. The installation's a little different. So Xamarin Forms always lived as a NuGet package. You would just slap it into your app from NuGet, and happy days. Whereas .NET Maui is actually been added into .NET, into the SDK, and so it's now available as what we call a .NET workload. So if you can kind of think of it like how ASP.NET Core is a workload that's baked into the .NET SDK, so is .NET Maui. And then one of the biggest differences, because we are finally breaking and bringing everybody up to date with things like .NET 6, we can change how we architect our solutions. So if you ever had a Xamarin Forms app, if you ever saw code for a Xamarin Forms app, you would have seen at least 3 different C# projects in there. One would typically be your .NET Standard project. Then you would have an iOS specific project, and you had an Android specific project. And if you were also running on Windows, you had a Windows specific project. And with .NET Maui, we can do everything in one single project. And this is really, really exciting because, again, it makes our lives as developers easier. So things like when you have lots of projects and you're sharing code in, say, your .NET Standard library between them, it can make things like accessing platform-specific code difficult, because now you have to know how do you get back from .NET Standard into the iOS code, and for that you need to know about inversion of control and dependency injection. So there's a really steep learning curve here in Xamarin Forms because of this. In .NET Maui, and again we'll see this in a second, we can take advantage of partial classes. We can take advantage of if-def compiler directives just to do it all in our one project. So drastically lowers the learning curve and also the amount of code we need to write to do a lot of things, which is really exciting. So with all that being said, let's dive into the .NET Maui source code. But I tell you what, before we do that, Sam, what questions are popping up in the chat, or what questions do you have so far about .NET Maui?
I have a few. This would be a good time to kind of mention, if anybody does have questions, they can drop them in chat, and I will bring them up to Brandon, and we can try to get them answered. Otherwise, they can always follow up with you, I think, and get those answered. But
of course,
so I guess my question is, there's that layer of different frameworks you can choose for how you're actually going to implement your app. And it seems like that's a big architectural decision as far as whether you're going to use XAML or Blazor or Comet.
Mm-hmm.
How do you recommend somebody approach that decision problem? Like, which one should they choose? Is it just something that's familiar, that they're familiar with and want to use, or are there certain things that fit certain types of apps?
Yeah, I mean that's basically it, right? Like, go with the technology you know. Maybe you're coming from a Flutter background where you're familiar with, or most familiar with, the model view update architecture, and you like doing everything in code with the fluent extension methods, then yeah, go with Comet. If you're coming from more of a WinForms, WPF, UWP background, you already know and love XAML, then you can go with the XAML and Mvvm UI framework, or maybe you're a Blazor developer. Because at the end of the day, really all these UI frameworks are doing is plugging into this powerful .NET Maui interface, and the code that gets generated is all done for you. So as long as the UI framework implements the interface, then .NET Maui can take it from there. So the only one caveat I'll give for that is Comet is, like I mentioned earlier, still in the experimental stage. We're still playing around with this a bit at Microsoft, so things may change, APIs may get updated, some breaking changes might happen before this kind of grows up into a fully released library. But for doing things with the Blazor web views or in XAML, all of that is totally released, totally supported, so you don't have to worry about any of that, at least today. Hopefully one day we'll be able to promote Comet up and get it out of the experimental phase.
Okay, so that was actually a question we just had from Homero. They were asking, is Comet production ready? And it sounds like no.
No. So, yeah, I mean, Homero, if you want to try it and it works and you're able to publish apps to the App Store with it, great. But just keep in mind the way Microsoft uses this experimental tag. It essentially implies that Microsoft could just drop support for Comet tomorrow. I mean, I doubt it would. I mean, Comet's open source. It's in the .NET org on GitHub. So likely what would happen is just engineers would be pulled away from it, and the code would still be there and you'd be able to use it. But Yeah, that's the one downside with experimental is when we start talking about like legally speaking at Microsoft, if there's a bug in the UI framework for Blazor, the XAML UI frameworks, then Microsoft has promised that we've got engineers behind it. We're going to fix it. There's SLAs, and if you get enterprise contracts, blah, blah, blah. All that is officially there and supported. Whereas with Comet, if you do find a bug in its implementation, then that guarantee just isn't there yet. So that's kind of the other side of the experimental tag. And what that means is that kind of use it at your own risk. But yeah, try it out. Ultimately, the way we get Comet promoted out of experimental is more people trying it out, more people using it, more people recommending it. And so the more conversations we can have about Comet, the better, because then that's how we can go to our leadership and say, hey, we need to make this a thing. And fun fact, that's actually what happened with Blazor. Blazor started out as an experimental framework. It was just Steve Sanderson, one of our genius engineers here at Microsoft, just kind of slapped something together and said, hey, look at this. Isn't this cool? And everyone was like, yes, I love that. I want more of this Blazor stuff. And then we were able to get an engineering team behind it and promote it away from experimental. So I'm personally hoping the same thing happens with Comet.
So you actually mentioned Comet is open source. I did want to, is there open opportunity for the community to maybe get involved and start contributing to that project or helping out with the development there?
Yeah, of course. Let's see. Let's bring up a little GitHub. So this is the repo we'll be diving into. This is the official .NET Maui repo. But if we back up a little bit to the .NET org, and let's cheat and just type in Comet here. Boop. There it is. So totally open source. If you want, you can open up a pull request or open up an issue and chat about anything you find in it, or fork it and build your own kind of thing. But let's see, does he have? Yeah, there we go. So here's a good example of what code would look like in .NET or in Comet. So yeah, check it out. Like I said, the way we eventually promote this out of experimental is via the community. So the more people we get talking about it, and the more conversations that are happening, and the more activity that happens on the repo, the better, because we can use all that data to go back to the leadership at Microsoft who has the buckets of money and say, give us one of those buckets for Comet. We're doing this.
All right. One final question we have from Doomroot, which is an awesome name. Are there performance differences between .NET Maui versus Blazor versus, say, Uno or Comet? Like, is that a consideration that people will want to test for their app, or?
Good question. I'll guarantee that there are, but I think the question is probably how impactful are they? Like, does a .NET Maui app built using the Blazor app model load 5 milliseconds faster, 10 milliseconds faster, 10 milliseconds slower? I don't know that off the top of my head, but I do know that performance was one of the biggest things for the .NET Maui engineering team. There was actually an amazing blog post that was just published. I should dig up that URL. I'll add that URL to the webpage down here that I put together for us, because it's probably like an 80-page blog post that talked about every fine-tuning performance metric that they went through. So yeah, with the officially supported libraries, you're going to be good. You don't really need to worry about that. And I'll say, I assume the same will be true for Comet, if it's not already.
Awesome. Thank you so much. I think that's it for questions so far. So I'll just let you show off some source code, I think.
Yeah, let's dive into some code. So
awesome.
Let's jump back to one more. There we go. So yeah, so this is the .NET Maui repo. Like I mentioned, it's totally open source. So feel free to come in, check it out, open up issues, discussions, pull requests. But let's start out. Let's see, can I do one more? There we go. So if we dig into the source folder, this is where we can start seeing that architecture that we were showing off. So for example, let's see if I can show these side by side like this and this. There we go. So right now, all we've done is clicked on the source folder inside the .NET Maui repo, and this is where we can start to see the split between these UI frameworks and the interface layer. So this Blazor WebView folder, this is where we'll find the UI framework for Blazor. The .NET Maui XAML stuff all lives in this one called controls. And we're going to actually start by going into the interface layer, which is the core .NET Maui stuff. So if we dive into core, and then it's got its own source folder, and ironically it has another folder called core, but this folder is where all of the interfaces live. So if we look at this, so iButton, iLabel, iImage, if we tap on something like iLabel, we'll start to get a sense for how this was all architected. So again, if you wanted to build your own cross-platform UI, you can plug it into Maui just by implementing an iLabel interface. And what does a label need? Well, it has this text decorations enum, which that's how you can define things like underline, strike through, things like line height, like how tall is the line height going to be. And we can also see that the interface also implements interfaces. So things like a label is going to have text on it, so it implements the iText interface. So label is going to have, we're going to have to align that text. A label is a view, so it's meaning it's going to appear on the screen, which means it needs to know things like width, height, etc. And you can always dig deeper into these, right? Like we could zoom out and go into what does iText look like? Well, as you can probably guess, text needs a string text. What? And then even that implements iText style, and text style requires things like we need to know the color for the text, the font, the character spacing. So everything that was done here was all very deliberate. We want to leverage as many interfaces as possible. And these are also super helpful for library creators. So one of my big open source libraries that I maintain is called the .NET Maui Community Toolkit, which highly recommend it for all .NET Maui developers out there, because it basically gives you a lot of things, like all that code you're copy and pasting between your apps. We put that in the toolkit for you. So things like converters, behaviors, we've created our own custom views, like pop-up view or drawing view. That's all there in the toolkit. And one of the things that I loved when putting this library together was, again, all we had to do was reference these interfaces. So if we wanted to extend or add any new features, we could say, hey, if it implements iText style, then extend it doing X, Y, and Z. So really, really helpful for library creators, anybody that wants to create a .NET Maui library as well. All right, so we have all these interfaces, right? How does .NET Maui know what to do for those interfaces? And for that, we call those handlers. So handlers essentially handle the translation between iButton and an iOS UI button. So let's check out, since we started with label, let's stick with label. And if we look at a label handler, well, actually, first of all, something you'll notice real quick, we have labelhandler.cs, labelhandler.ios.cs, labelhandler.android.cs. And all of this is possible because the code's all in one shared or one single project. So we have all these frameworks, Android, and actually, this is cool. I didn't mention this earlier. Samsung opened a pull request about about 13 days ago that added support for their Tizen platform into .NET Maui. So .NET Maui actually supports Tizen now, even though nobody on the Microsoft engineering team did it. The awesome, crazy smart developers at Samsung said, we'd love to leverage .NET Maui for our operating system Tizen. Here you go. Here's a pull request. And so if you're familiar with creating apps for Samsung TVs or Samsung watches, that's all done on their Tizen platform. And we can do that with .NET Maui too. So .NET Maui is already growing. my slides are already out of date, which is always a good thing. But yeah, let's click on Label Handler. And here is kind of where we can start to see how the magic happens. So there's this concept of property mappers inside .NET Maui. And what a property mapper is, it's just a dictionary. It's just a fancy dictionary for all intents and purposes. Because what it does is it maps the property. So in this case, iLabel.background or iTextile.character spacing. It connects that to a method. So there is a method called map character spacing that anytime this iTextile.character spacing property changes on a label, this method's going to be called. So one thing you might notice though, if we keep scrolling down, we're going to hit the end of the file. There's no methods in this class anywhere called map character spacing. So what the heck, right? I just told you we're mapping this property to the action that happens when the property changes, but where is that? And this is part of that new exciting architecture I was mentioning earlier, where we can leverage partial classes in our apps now. So Label Handler is a partial class, and if we go back, all of these other classes are also partial classes. So labelhandler.android.cs, this file only compiles when you compile your app for Android. So the compiler knows how to handle this, and when you compile for iOS, this .android.cs file just gets totally ignored. It's like it doesn't even exist. But when you compile for Android, the compiler includes it. And so what we see here is it's also a partial class called Label Handler, just like labelhandler.cs is. And in here, because now this is Android-specific code, this is only code that'll build on Android, this is where we can start actually referencing those Android APIs. And so things like map text, when this method runs, it actually just calls this method called update text plain text, or map text color calls update text color. And these are Android APIs. These APIs are from the Android SDK that, again, all this technology, all we did was really we just wrapped all those all those Android APIs, all those iOS APIs, brought them to us C# developers. And so what's going on here is the handler has a platform view. What does that mean? Well, if we scroll up here, we can see iLabel maps to an app-compat text view. And again, app-compat text view, this is an Android API. Even the using statements up here, you can see we're using Android X appcompat.widget, Android.views. We are now looking at Android code in C# in the .NET Maui library, all because we just changed that file name to .android.cs. So again, anytime a property changes, the property mapper that we saw a minute ago defines what method to call, and then we just have to write these methods for each of those properties and say, hey, here on Android, here's how we need to handle it when the text changes or the text color changes. And likewise on iOS, we'll see all the same methods. So here's map text, and here's the API that iOS uses for it, for its platform-specific code. So really cool how the team architected this and put everything together. And you can also easily override any of those. You can add your own property mapper, and we'll see that. Oh goodness, we only have 20 minutes left. All right, let's zoom forward, because really what we're talking about is how do we make apps in .NET Maui, and that code lives up here. So let's just glance at this, and then let's get into making our first .NET Maui app together. But we can see up here that, let's see, where are we down here? We were playing with labels earlier. So maybe just do, there we go. Jump straight to it. So on the UI framework side, so now if you remember our chart up here, we're now looking at this code. Well, this code also implements all those interfaces. So if we dig deep into this enough, we'll see where it implements iLabel. But now, this is where it implements bindable properties, stuff for our MVVM stuff that we need in XAML to handle all our labels. And so really we just see a whole bunch of properties, and there we go. So like text, line break mode, all of these, text color. This is where the UI framework side implements the same interface that then gets translated on down here at the code we saw a minute ago into that Android label, that iOS label. So, really, really cool. So if you got a couple questions, we can take a minute while I start firing up some of our .NET Maui source code.
So I think my question is, how do you handle platform-specific code? So certain platforms will approach different things differently. If you want to open a file on a mobile device versus, say, Windows, that's a different thing. You're going to get different UIs and a different experience. How do you handle that in an app that shares all of its code with one another and kind of condenses everything?
What a great transition. So let's actually look at that in the code. So actually, I just point out a step I just skipped past. So I'm on my Mac. I love using Visual Studio for Mac. And if we just go new, and then if we go down to multi-platform app, then we can see all of our .NET Maui apps. So this is where the templates exist if you want to create your .NET Maui app using Blazor, or if we're just going to do it like we will today in XAML. So we'll go ahead and continue with this. We'll call it be a very innovative. We'll use a really clever name like my app. And when we click create, then we've got our first .NET Maui app out of the box. And just to show it off so that we can see the app running side by side with the code here, I'm going to run it here on my Mac. So we'll give this a second to build, and I think the answer to one of your questions, it's not included in the template anymore. Dang. Okay. We'll add some code.
Well, one thing I did want to add quick is you can also do this from the command line, right? You can run .NET New and create Maui directly from your command line if you have, I think it's C# 6.3.
Yeah, absolutely. So just to show that off real quick, let's zoom into my terminal down here. And so if I wanted to do the same exact thing, we can say .NET New Maui. And then if we say -n, then we can name it to be, Brandon's Maui app. And if I spell stuff correctly, there we go. So if I open Finder pointing to my desktop, there's Brandon's Maui app, but it's the same exact template. Everything's the same. But the benefit here is if you wanted to, you could then do this in Visual Studio Code or your editor of choice, because everything we're doing here in Visual Studio, specifically Visual Studio for Mac, you can do it in the command line. So for example, if I navigate into my app that we just created with the command line, if I wanted to build it, I can say .NET build. and this will compile my code. And actually, I just think, yeah, there's our Mac app. So this is the app that we kicked off from Visual Studio. Let's give this a second to build, because I'll show you we can also build and run the app here in the command line. So right now it's just compiling it. This isn't going to run the app that we created on the terminal just yet. But if it doesn't take too long, I'll kick it off for us. Actually,
So we do have a question kind of related to that from Homero, who's asking if there's support intended for Visual Studio Code and being able to actually build things. I've run into issues, for example, with XAML inside of .NET Code, where tracing bindings and things through .NET Code or VS Code is not necessarily as easy as maybe Visual Studio. Do you have recommendations for that, or?
Yeah. So real quick, just want to show. Here's how you can run the app via the command line. So if a second ago I just said .NET build, enter, boom, it would compile, great. But if we say -t:/run, and then specify which platform we want to run on. So in this case, I said, let's do it on the Mac via Mac Catalyst. Then here it is. And you can even see in the title up here, it says Brandon's Maui app, which is the one created in the terminal, whereas this one's my app, which I created in Visual Studio. Yeah, Sam, the answer to your question, it kind of sucks. To be honest, this is more of a political thing internally at Microsoft than anything else, where the Visual Studio team doesn't want to be cannibalized by Visual Studio Code. So all the investment for .NET, for C#, all those great tools we have included in Visual Studio go into Visual Studio, and VS Code's kind of still out there. It's like, hi, I'm still here. And what the philosophy today is, which I don't agree with, but somebody who makes more money than me and controls budgets has decided, is that the community can contribute extensions for C#, .NET, and this stuff into Visual Studio Code. But as far as Microsoft's concerned, they're going to put the money into Visual Studio. So kind of a bummer. I don't agree with it. If you don't agree with it either, make your voices heard, because yeah, Visual Studio Code is great. I use it all the time. But here we are. So let's see. Gosh, only about 10 minutes left. We are flying through this. So let's jump back to the app. Let's look at how do we build and write our code for our mobile app. And actually, maybe something cool I'll kick off here is I'll run it on iOS, I'll run it on Android, and we can see stuff side by side. Oh no, that just stopped. Whoops. When I changed to iOS, it stopped running our Mac Catalyst app. Let's bring that back up real quick. Pause for effect. There we go. So what we're looking at here is, this is the code that created this page. And we're going to see it here on my iOS simulator in a bit too. So here's that same code running on iOS. And this one's kind of cool because you'll notice the background's black here and the background's white here. Well, that's because my Mac is running with dark theme, and the app has defaulted to the dark theme. Whereas on iOS, if I change this to dark theme, I guess I have to recompile it. You can see the title bar switching here as I change it back and forth. But if we relaunch this, let's see what happens if we go boop. Let's see, make sure we're in dark theme. Run it again. Come on. There we go. Boom. So little fun surprise that we get for free out of the box. But yeah, let's look at this XAML code over here, because it's pretty straightforward, especially if you've done any XAML before. And so what we've created is what we call a vertical stack layout. Kind of does exactly what it sounds like. It'll stack items vertically on the page. So with a vertical stack layout, we can just add as many items, as many children as we want into it. And whatever the order is into which we've added, that's the order they'll appear on the screen. So we added the image first of our .NET bot. That's why the .NET bot appears on top. And then next we added in a label that says hello world. That's why it says hello world here. And same with the next label, same with the button. And by the way, we can click this button and look how fun that is. So if we wanted to do something, let's see, we could add, I don't know, maybe we add another label above that image and we say something like, welcome to the, welcome to the Reactor Show. And we could, let's bump that font size up to 100, because why not? And then let's run that code and see what happens. We should have a big label appearing up top. And again, that's just because of where we added it into our vertical stack layout. So apps launching. Oh, goodness. Yeah, that's definitely a large font. But that's okay, because this vertical stack layout is actually wrapped inside of a scroll view. So a scroll view, probably similar, does just what it sounds like, and it allows us to scroll any content that's inside it. So because we're in a scroll view, we can still scroll down and see the actual app down here. Whew! All right. Sam, how are we doing so far? What questions do we have?
Good. My question is with data bindings. Do they work the same as something like WPF, where you need to have a property notifier to say, hey, this got updated? Go and update my UI.
Yeah, good question. So yeah, it's MVVM. I mean, the template doesn't come with a view model, but yeah, if you're familiar with doing data bindings in any platform, Xamarin, WPF, WinForms, UWP, same. The syntax might be a little different from UWP's binding syntax or WinForms binding syntax, but yeah, same idea where we can have a view model that contains all of the business logic and none of the UI, and we can have a view which contains all of the UI and none of the business logic. And by business logic, I mean like what happens when you click a button. Well, we can move that code to a different class, and then we can completely separate our UI from our business logic. and that's where the view models come in. So yeah, we don't have bindings here. If we have a minute, I can pull up a sample app. Actually, I'll do that now while we're answering questions. I'll on another monitor pull up another app that I've made that we can look at bindings and all that fun stuff.
So another question I had actually while you're doing that. Names have changed since WPF and UWP for components. They reflect more Xamarin stuff, and that's not something that I'm personally familiar with. And so that's something that I found I kept getting lost in. Is I'd be looking for like a stack panel, and stack panels don't exist. They're vertical stack layouts. And so is there a way for me to quickly find like how did these names change and figure out what I'm actually looking for? Is there a good way place for me to go?
Good question. I don't know is my personal answer. Yeah, if we go back in time to back when Xamarin was created, and it implemented XAML, like we see here, it didn't use the same XAML as, say, UWP or WinForms. It is XAML, but yeah, like the names of things are a little different. Yeah, I don't know. I don't know if there is a chart that shows if you're used to UWP, here's what it's called for .NET Maui, but I'd say that's a great idea if it doesn't exist. And highly recommend anybody out there listening to create something like that.
All right, we did have one request for you to increase the resolution of your code.
Yeah, of course.
Thank you so much.
All right, so this is... So I gave a shout out to the community toolkit earlier. This is the source code for that community toolkit, and inside of it we have a sample app that shows off everything you can do with it. Maybe we'll build this in the background, see if this has enough time to compile and launch. And oh gosh, the 2 minutes we have left. But to show off what we were talking about a second ago with bindings, let's see if we can find... Does one of these have a binding? Yes. So, for example, actually that's got a lot of bindings. Maybe we find something a little similar. Okay. So, let's show this. And let's see if I can show its view model for, this is the compare converter. Showing off our compare converter and how it works. So the compare converter view model has a property here called slider value. And yeah, anytime that slider value changes, we call this set property method, which is, let's see, how do we implement this? We are using, oh, cool. We're actually using, there's a toolkit, another community toolkit called the Mvvm Toolkit, where this is really cool, where you can just add this iNotifyPropertyChanged attribute, and it'll just implement all the things for you. So if you're familiar with having to create your own implementation of iNotifyPropertyChanged, the community toolkit's got your back. It'll do that for you. There's even a cool feature here where we're not showing it off in this specific example, but you can also just get rid of all that code that we had there and say that this is an observable property. And then the Mvvm community toolkit will generate that code for us using code generators, which is really, really cool. So if we look back at the XAML, there's a slider on this page. A slider, if you picture like a 0 to 100 range and a little button you could slide back and forth to set a specific value. That's what we call a slider in .NET Maui. Looks like we're going from 0 to 1 here. But yeah, we just say that the value of the slider is actually a binding to that slider value property that exists in the view model. And there you go. We've just moved all of that logic out of the view and into a different class, which gives us much more flexibility. It makes unit testing our business logic a lot easier too. Good question. What other questions do you have, Sam? We've got about 3 minutes left.
Yeah, there's definitely still a chance for if anybody in the community has questions. Otherwise, I can fill in. But so it actually the bindings actually do look fairly similar. I've dropped links to your slides into chat. I'll do that again actually. So slides, we'll just do that. And that goes to your website. So you can find the samples and stuff that Brandon's been showing off there. What else? What about so different form factors of devices? I think you showed this in your initial demo of like mobile versus desktop apps, where you're showing the weather app. Mm-hmm. Different apps or different form factors of devices are going to want to display content in different ways. Like if you have a big TV, for example, you probably want to use that space a little bit differently than maybe a 5-inch phone.
Yep.
So
Absolutely.
How does that look? How do you interact with?
Oh, right, yeah.
That
was the question that brought us into the code, and I totally forgot about it. So we'll show a couple different things, or at least one or two. So, like I mentioned at the top, like there's only one C# project here, and the way we're able to build for Android, iOS, Mac OS, Windows, the secret sauce is here. So we have this target frameworks with an S, and this is where we say that this app is going to build for .NET 6 Android, iOS, Mac Catalyst. Windows needs a couple extra little things, so it's in its own target frameworks down here. But what that allows us to do is here, I can say things like if iOS, or there's all these, like if you're on iOS 12.1 or greater. So we can use compiler directives to jump straight into that. And in here, we can do things like say var button. Well, actually, let's change this to iOS so that code lights up. Hopefully. Maybe if we close it, come back. Let's see. Or is that supposed to be all capitalized? There we go. My typo. So yeah, this is now, we know we're only on iOS. This code is only going to compile for iOS. And so we can access things like the UI button API, which is in the UI kit library on iOS. Other ways you can do it. So you can say if, let's see if I can get this operating system is Android. We can then put some Android specific code in here. As you can imagine, there's is Android, is Linux, is iOS, is Android version at least, so you can get real specific with stuff like, is this at least Android version 31? Then run this code. And then if we go back to XAML, oh goodness, we're at the top of the hour. Let's see. How's my... Oh goodness. How do you do this in XAML? I don't remember off the top of my head. There is a on platform. Let's learn this together. On platform, .NET, Maui, XAML. Dun, 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 dun. Jump straight to it. There we go. Give me an example I can copy paste. There we go. Okay, I was on the right track. So if we say on platform here, so maybe we want the default to be for this image height, right? Maybe the default will keep it 200, but on iOS we want it to be I guess probably that's all fine. Like you mentioned, it's really the desktop stuff we want bigger images. And so maybe we want it 1,000 pixels on Mac Catalyst, or for WinUI, also 1,000 pixels. So yeah, we've got so many options. We can do it here in XAML. We can do it here in C# with either compiler directives. We can do it here in C# with things like operating system.isAndroid. And if you also really wanted to, we could even use partial classes. So I could make something like Maui program.ios.cs, and kind of like we saw in the library source code that we looked at earlier, as long as we make this a partial class and partial class. Well, now I'm just going to get yelled at because now they both have to be static, and I'm creating duplicate constructors. But yeah, so lots and lots of different options. Is one better than the other? I don't know, not really. Kind of depends on what you like as an app developer and how you like to architect your things. But great question. I'm glad you reminded me to bring that back up.
Awesome. Thank you so much. This has been super cool. Where should people go to find more about Maui? Where should they go to learn more about it?
Yeah, absolutely. We have a Microsoft Learn module that's totally focused on helping you learn everything about Maui. So I believe we have the link to that. Is that right, Sam?
Yeah. We'll drop the link in chat just a minute. We do have a question here quickly from, what do you do for multiple displays or very large displays? I actually intended to ask this too, because I have a Surface Duo, and I believe there's support for foldable and multiple device screens. So,
yeah. So let's see. Let's type in .NET Maui Windows. Let's see how this works. Multi-platform. Oh shoot. I was really hoping that would work. Probably multiple windows. Multi-window apps. There we go. I knew there was something in there. Let's see. So if we skip the code. Where is the code I'm looking for? Maybe we should just go the actual docs. That makes more sense. Sorry, Michael. Love you, man. So here we go. So there's a method we can override inside of the application class, which we come back to app.cs. So for us, that would be, there you go. So looks like there's create window, close window. What was the other one? Open window. That makes sense. So yeah, you can have multiple windows running off your same single application too, which, yeah, that's super popular in desktop as well. So it makes a lot of sense to be able to maybe pop open a new window over here so you can do something, or your users can do things side by side. But yeah, multi-window support, totally available in .NET Maui.
Awesome. Cool. I think that's mostly all the time we have. If people joined late and they want to catch the rest of this session, or we've also been going through other things that were announced at Build, including like Azure container apps. I'm jumping over myself, and a few other things. If those are things you're interested in, they're all on the Microsoft Reactor YouTube channel, so you can go and check them out there, including this one, which should be up in a couple of days at the most. So other than that, thank you so much, Brandon, for joining us. We do have a Reactor survey here. We use this just to kind of track how we did. If these are the kind of things that are helpful and you want to see more of them, you can fill that survey out and let us know. Or if you want us to do something else that maybe isn't this, you can also do that through that survey. So other than that, anything you want to say, Brandon? Or
No, it sounds good. Thanks so much for having me, Sam. And yeah, if anybody has any questions, feel free to check out that webpage I put together for us. It's codetraveler.io/update-Maui. That's where you can find all the stuff we showed off today. You can find some additional sample apps. I've added the link to the Microsoft Learn module there. So if you want to get started with Maui, you can find everything we talked about there. And yeah, feel free to reach out to me on Twitter if there's any questions we didn't get around to today. So thanks again.
Awesome.
Thank you, everyone, for joining, and thank you to our speakers. I also do have one thing to mention. If you're looking for more Microsoft or more content on Microsoft Build, there are 11 sessions highlighting the best of Microsoft Build, as well as a screening of the Top Gun Maverick movie in the cinemas across the U.S., and you can find more information in the chat. I've also added the 11 sessions there as well. So thank you, everyone. Until next time.
Thanks, everyone.